Hello everyone, this is Brock Skaggs, and in this video we're going to look at for next loops. And so looping and iteration is a big thing with code. Obviously there's a lot of different examples, and just a couple examples. So you have a directory full of a bunch of files and you want to inspect each file. Say there's 1,000 files. Well, it'd take very long for you to physically, of course, open each file, do whatever you're going to do to it, close each file, open the next file, and so forth. And so the nice thing, of course, with coding and for next loops and for each loops and so forth, are you can basically write code so that each file is opened, does the whatever action you do, closed, and then it moves on to the next file. Obviously the computer can whip through those things very, very quickly compared to us mere mortals can. And so one of those types of loops is the for next loop. And so it works by basically having a counting integer. And so the integer goes 1, 2, 3, 4, 5, 6, up to some maximum number through the number of loops there. And so I usually use I as my counting integer, but it doesn't have to. You can really use whatever variable name that you want for that. And so a simple task we're going to look at here is let's create a subroutine to sum the first n number of positive integers. And so I'm just hopping into the VBA side of Excel. I'll insert a standard codes module, and I'll say public sum integers. And let's say there's going to be some max value. So dim max val as integer. I'm just going to go ahead and say it's long in case we get real big. And say max val is equal to, say, 25. And so we want to sum the numbers 1 plus 2 plus 3 plus 4 plus 5 all the way up to 25. And so how we would do this programmatically, well, we could use a for next loop to do that. And so, well, let's dim I as integer. It'll be our counting variable, and we can say something like for I is equal to 1 to max value next I. And so here what we're saying is, okay, I'm going to start I at 1, and then I'm going to increase it each time by 1 till I get to the max value of 25. And so we need a way to store the result of this, and I'll say dim result as integer. Let's dim the result as long as well. That we could get somewhat big, possibly. Probably won't for 25, but just in case. And we'll say result, and here it's equal to result plus I. So every time through this for loop, a result's going to be added to, or the result's going to be increased by the amount of I, and so we'll store it each time. And then after this, we'll come down here and say debug.print final sum and result, and so this should give us the result that we're looking for. And so let's go ahead and run this. I'll put a breakpoint right here, and I'll come in here to the watch and add a result to it. And so right now, as you can see, the watch shows the result is 0. And so I'll hit F8, I'll run through here, now it's 1, now it's 3, it's 1 plus 2 is 3, now it's 6, see how the result keeps increasing here, steadily along until we get to 25 runs through the for loop. And so I'll just let it run to the end here, and we get to a final sum of 325. And so, okay, we should be able to test this a little bit inside of Excel. We'll come down here and we'll go 1 to 25 here, and then if I sum that up, it is indeed 325. And so it looks like our code is working correctly. Just kind of show you the difference between thoughts, and here is basically the programmer's code. That's basically what I was doing here. If you're a mathematician, you might say, well, I can prove this with a little bit of mathematical rigor and using mathematical induction. And so what I've got on the screen here is a way to prove that the sum of I equals 1 to n, so it goes to I is 1 plus 2 plus 3 all the way up to n, ends up being the expression n times n plus 1 over 2. I won't go into the details here, but this is basically a proof that I think was first done by Gauss a long time ago. And so if it ends up n being 20, you end up with 210, which is what the example is showing here in both code as well as using math. And so one way you can modify your for loops, though, if you don't want to step by 1 each time, is to add a step statement. And that's what I've got in the next example here. And so I'll come down here, pull except, highlight cells, and we can do a very similar thing. I'll say dim I as integer, and we'll say now for I is equal to 0 to 10 next I. So now here, notice we're not starting at 1, but we're starting at 0. And this would go through and step 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just to show that we're going to be doing something, let's go and say something like set, define a range first, dim RNG as range, set RNG equal to sheaf1.range A1. And so what we did here is declare a range variable. We're setting that range variable equal to the range A1 on sheet 1. And then we'll do something like range.offset. We want to go rows, so we'll say I, 0 dot interior dot color index is equal to 3. And so what this will do is actually paint the background of each of these cells red. And so here, I'll go ahead and just evaluate this. And it ran, and now as you can see, it made those cells red. I'll use Format Painter to go ahead and take these off. Say I didn't want every one of those, but say I just wanted the every other one to be red. And so I could do that right here and just say, well, let's step this by 2. And so this will be 0, 2, 4, 6, 8, and 10. Actually, I can show you this right here by just stepping through and hitting F8 each time and hovering. We should be able to say I is 0, now it's I is 2, I is 4, I is 6, I is 8, and I is 10 there. And so that's one way to control your for loops if you don't want to step in increments of 1, but instead increments of 2 in this case. And of course you can change that however you see fit in your code. And so that's one modification of a for loop. Another thing that you might have in a for loop is a condition that says, hey, I need to exit the for loop before my for loop completes. So I can show that for loop exit. And so for this, let's have dim I as integer. Let's say something like for I equals 1 to 100 next I. And we're going to be printing something in the debug screen, so I'll close that off. And so right now it's going to go 1, 2, 3, 4, 5, 6, 7, so on and so forth. I'll just print I to the debug screen. But say I don't want to print all the way to 100. Say I'm searching for something, and so I'm searching for a certain result to happen, and then I want to exit out of the for loop. In this case, we'll say if I is becomes greater than or equal to 10, then we'll do some action, and in that action we will actually exit the for. And so this is going to prematurely stop it as soon as we get to 10. So we should have 1 through 10 printed in the debug, and then it quit at that point. So we're just hitting F5 and running this. I've got 1 all the way down to 10. So again, what happens here, we're going through the for loop. First time is 1, it prints 1, and 1 is not greater than or equal to 10, so we move on. Goes through the same thing, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 happens. 10 gets printed. It says that 10 is greater than or equal to 10, so this value is true, and then this statement right here exits the for loop. And so it's a way for us to prematurely jump out of the for loop in the case that some event happens there. One other aspect of for loops that I wanted to cover in this video is the fact that we can have for loops that are nested within each other. And so at this point we just have a single for loop, but let's nest something together. And so we can have public sub for loop nested. That's just a test subroutine. And so here I'll say, well, dim I is integer, and we'll also dim j as integer. And so we'll need 2 different counting variables here. And also something like for I is equal to 1 to 5 next I. And I can also come in here and say for j is equal to 1 to 3 next j. And so one of the things I'm being sure to do here is control my indents. And that helps me see what's in the first for loop and what's happening in the second for loop. And I'll just say I come here and say something like debug.print just to show the use of this. And we'll just print I comma j. And let's see, forgot the ampersand here. And so let's go ahead and just breakpoint this first. We can kind of walk through it. I'll run it through here. So right now we hit F8. So now I is 1. J is going to start rolling through here. And so right now I is 1 and j is 1, and we print it to the screen. Now we stick in the j loop. Now j gets incremented to 2, so it's 1 comma 2. Now it's 1 comma 3. After we finish this interior for loop, now we're going to jump back out to the top for loop, and now I is going to be 2, and we do the same thing, 2 1 2 2 2 3. Now we jump back out. Now I becomes 3 2 3 2 3 3, so on and so forth, until we run through the extent of all those nested for loop iterations. And so this is something you might have as well. Here I've kind of got like this rectangular grid, the way I have it in my mind, that maybe the I's represent rows and the J's represent columns there, if you were trying to iterate through something and make some sort of grid, two-dimensional grid structure happen there. And so that's kind of the details associated with for loops. We started off pretty basic, right, with just a simple for loop where you're summing the first n number of positive integers. We did some highlighting cells to illustrate that you can change the step size. Instead of just 1 being the default, you just put step as the keyword and then put the value there. You can also exit for loops prematurely with an exit for statement. Usually you can have something like an if statement in there to detect when you want to exit, and then be evaluated when it gets true. And then also, of course, you can nest for loops together in order to accomplish specific tasks as well. Let's go back to the PowerPoint, make sure we hit everything. Did the exit for, did some nesting in there, and so it looks like we're in good shape. So again, reference here that I've been using for some of the background material to these concepts. So thank you for watching the video. Hopefully this helps you get acquainted with for next loops and you can start using them in your code. Thanks again.